All right, how's everybody doing tonight? Doing okay? Pins on the overhead, plus I have it on the board, and I'll go ahead and leave it on the board there and take it off the overhead so we can get started. I did send everybody an email on a link to a website I put up for updates on what's going on in negotiation. Looks like this. You can avail yourself after class and beyond to look at it. It's got an FAQ that the Faculty Association put together. It's pretty good. Answers like 16 FAQ questions you could have, and you can just go to any one of them. And like are the two sides that far apart, which is a common question. Gives you the answer on that. And so it also has an area in here for negotiation updates, like tonight and tomorrow at 5:30. The faculty contract negotiation team and board of trustees is going to be meeting for further contract negotiations. So hopefully some good will come out of that. And then also there's a documents section that gives just documents. One of them is the FAQ document that's in here in a PDF format. If you want to distribute that to other folks, you can do that. And then some of the last final offers from faculty and also the board. And then there's a link here to the We Are RVC Facebook group, and then a contact us if you have any further questions. So avail yourself to that. Tell me what you think of it, like it, hate it, want some more information or whatever, let me know. We can add some more information into that, okay? So this is in your inbox, the information is, and I will update it as I get information. So at the end of every negotiation and every bit of info, I'll put it in the negotiation updates area probably over here to help you out. And so that'll keep you posted. And also if you go to the We Are RVC group, it does have a lot of information there as well from not only myself but other faculty members and students that are involved. I know some of you are quite involved, so some of you aren't because you work full time, you just don't have time to mess with it. So that's why it's good to go to sites that have some information for you to help you out. Okay, so that's what I know, and like I said, tonight and tomorrow night at 5:30, we're going to be meeting somewhere here on campus, and so that's good news. The negotiation committee was contacted by the board at 8:30 Monday morning after our vote strike on Friday, so that's a good sign. And in fact, there was inklings Friday late afternoon after our meeting to vote to strike. There was emails and texts already sent that they wanted to meet, so that's a good sign. Before that, the negotiating committee hadn't heard for 2 to 3 weeks from the board prior to Friday's meeting, so that's a good sign. So my hope is that it is resolved quickly, but until then, I'll try to keep you guys up to date as much as I can, all right? So this week is week 5. We're going to be going over network defenses tonight, talk about that. On Thursday, we're going to be doing a lab on spoofing the man in the middle. This is the Facebook spoof lab that I talked about and mentioned already. I tweaked it a little bit last semester, and basically we'll be using Kane-Enable, XAMPP. XAMPP is a web server type of application built on PHP. It also has a MySQL and PHP MyAdmin in there where you can build full-fledged websites and test it on your local computer. And then there's a Facebook page in there as well. And so the purpose of the lab is to show you first of all, how Kane-Enable works, which is using what's called ARP poisoning. And what they do, hackers use ARP poisoning to overwrite valid IP addresses with redirect spoofed IP addresses. And like in the lab, you will all go to facebook.com. It'll redirect you to an actual location here in the classroom that will look like the real Facebook page. I'll tell you to log in with a bogus username and password, not your real username and password. And then, because if you do a real name password, I will receive all of that, even though I'd delete the database afterwards anyway. But anyway, within a minute, I'll have everybody's username and password because it'll act like it's a failed login, and you let folks do it for a couple times and then turn off the redirect and can't enable, and then when they try to log in the second or third time, lo and behold, they're in the real Facebook site. And by that time, the hacker has all the username and passwords of the users in that domain that's logged into facebook.com. So this type of thing that we're going to be doing Thursday, this man-in-the-middle attack, is used a lot, believe it or not. And there are man-in-the-middle programs, Trojan programs, and malware out there that do this very thing. And so they will, like, an example I came up against was, this was a Trojan horse, or malware actually, that's been floating out there for about 3 or 4 years now. It happened last week. I had a computer that was working on doing some testing, and anytime you test anything in IT, a lot of times you have to turn off your firewall and also your antivirus to do penetration testing, like we've had to do in here sometimes. In fact, that, you know, the CD I gave you guys to port to USB, a lot of those apps your antivirus will catch and quarantine, or try to, and so it's easier probably just to, you know, turn it off for a bit or allow it to go through. But anyway, I was in the middle of doing some penetration testing on network, turned off the antivirus for a bit, and got a malware. I believe it was antivirus, Internet Security 2012. That's what it was. Internet Security 2012. You might have heard of it. Anybody heard of that virus that's floating around? It's pretty powerful. It's a new variant of Internet Security 2010 and 11. And what it is you go to a website, and this variant is, you click on it and do the I agree thing, and I agree on, say, a website to say view pictures or log into a page or whatever, and installs this variant. The immediate thing it does is it'll disable any antivirus you have on your computer. It'll kill it immediately. And then it will not let you go into Task Manager. It will not let you go into Internet Explorer after that. It will not let you go and run anything. It basically kills all processes from running. And there was a command prompt that I ended up using to kill the process. I found out what the process name was, did a command prompt, and I thought I'd email everybody that because it might happen to you possibly, or somebody you know. This only generally happens if you have antivirus turned off, for sure. Your antivirus should catch it. But this was so new, they said some antiviruses were not catching it. It just came out the end of January. That they renamed the executable. So anyway, it was pretty nasty because it actually did a lot of things the old one didn't do, the 2011 didn't do, and it embedded itself in the boot up to where when you start up your computer again, it even did more damage and started going in and infiltrating more into your computer. And so pretty nasty. I killed it and quarantined it pretty quick. But you know, the average user, if this would happen to them, I could see where it would be totally messed up within an hour or two of trying to play with it and trying to fix it. Yeah. Yep.
Not only did it, lock everything and you can't run the programs, hit everything, hit every single file.
Yes.
Changes all the permissions.
Yeah, it changes all the permissions. Yeah. Yeah, it just starts putting its fingers everywhere and starts going and doing crazy stuff. And yeah, the payload that hit me, the only payload that hit me was disabling Internet Explorer and any running applications in the processing at that time. I quickly figured out the process name and killed it, and then I was able to restart my antivirus program to do a scan, and sure enough, it caught those two malware files. That, well, I think it was, the file name was actually called Internet Security 2012.exe or something like that. And so yeah, and so I'll give you that command prompt I used, but it was pretty in depth what it did, and I hadn't experienced it yet, so it was kind of fun getting rid of it. I kind of enjoyed it, but the average user definitely wouldn't enjoy it. No, it was pretty nasty. Okay, so Yeah, Thursday we're gonna do that. We'll probably be here the entire, I know you guys all get here on time for the most part, but we will start right on time with the lab. This zip file actually has everything in it and the instructions as well. I'll have it set up usually on one of these computers up front, the computer that's gonna be the database type that gets all the data and stuff, kind of like the hacker computer, and then the man in the middle computer, and then you guys will be coming in, and what you'll do is just, go on your regular Facebook page, show you how it works, normal. I'll turn it on, then show you what happens when a man in the middle attack occurs. And then we'll look at the website and kind of see some ways you can, catch this from being a culprit. All right, so the security defenses, big part of network security. This goes over such things as one I want to cover tonight is enhanced security through network design. So basically a common mistake in network security is attempting to patch vulnerabilities in a weak network that was poorly conceived and implemented from the start. What this means is kind of like putting a Band-Aid on trying to take a Band-Aid approach to brain surgery, if that makes sense. And so, the wrong tools basically. You're trying to fix something that is much deeper, and a simple patch isn't going to fix it. And I always tell students, all the software and hardware you buy really does no good. They're only as good as the rules you set up. And hopefully in school you'll learn rules to set up within your network. Specifically, the Cisco class that goes over routers and switches is a good one I'd recommend, where you learn how to set up your rules on a Cisco router, which is really some basic commands you've got to learn. And then once you learn those commands, how to port that and to set up those rules. But Cisco devices can cost anywhere from $2,000 to $10,000. Routers can, but they're only as good as the rules set up on those devices. And that goes with anything with network security, even as basic as antivirus software. The antivirus software you use is only as good as your settings you put on the antivirus, like making sure the DAT files are updated all the time, making sure you have a scan periodically. I don't know how many people cancel scans out all the time, and end users will always cancel them out because they have work to do, okay? So that's why it's IT's job to make sure a scan happens in the middle of the night when they're not there. Because sometimes a scan on a large hard drive might take 2 or 3 hours to go through and do it all. But they don't have time to do that at 9 a.m. in the morning. It takes up a lot of resources, and it's not going to happen. And so even computers that have the most up-to-date of everything have to have some rules that are actually enforced, like a scan, a simple scan, like, can do wonders. Also, security in a network begins with the design of the network and includes what's called secure network technologies. First is subnetting. When we first began implementing network here on campus years ago, over 40 years ago now, we were on one called a flat network, one IP address range back then. And over the years, we've had to go into subnetting, which gives us multiple avenues for data to flow. But basically, the word subnetting, or the definition of subnetting is, first thing you need to know is IP addresses are made up of 2 addresses. You've got 4 octets in an IP address. Okay? One half of the octet, the first 2 octets, and the last 2 octets. One half of the octet is made up of the network address, and one part is the host of that. Okay? When you go into classful addressing, they split the network and host partitions of the IP address originally set, and then goes into subnetting or subnet addressing, which allows an IP address to be split anywhere. Networks can be essentially divided into 3 parts. You got your network, your subnet, and your host. And so, for instance, on your left part of the IP address, the 2 first octets, for the most part, is going to be the network address, and the last part would be your host address of that IP range. And you basically have all of those to deal with when you're setting up a network. So here we have an example here of a 186.98 network node. And then you'll notice those are throughout all of the, whether it be a router, whether it be a server, whether it be a computer, that 186.98. Then you'll notice the third octet, the IP portion of it, the IP range portion of it. 3.4, 3.3 are the two ranges here. And you remember you have from a .1 to a .255 or 253 generally is what they use within, no higher than 253 usually. And they have that range per octet. So 34, 35, 36, 37, 38, 39, 40, 41, so on and so forth. So they've got quite a bit of range when you begin subnetting. And what it allows you to do within a network is to route those network nodes to talk on the same network address, which is a 18698, but have different IP ranges. And the IP ranges, again, is that last two octets, the 3.4 and the 3.3. And each of those octets have a certain range that they'll let you go through. And the advantage of doing subnetting on networks is decreased network traffic, because when you have everything in one tunnel, you can think about shoving everything in one tunnel versus two tunnels. Okay, you're going to have more efficiency. You're going to have better bandwidth, throughput, and so broadcast to network hosts are generally limited to individual subnets. When you go into subnetting, each subnet is going to have its own separate subnet host to work with. Flexibility, the number of subnets and hosts on each subnet can be customized for each organization. And the great thing about subnetting is when you get into it, it is kind of hard getting into it and understanding how it works. But once you learn the main concepts of it, you can easily set up a 2 to 3, 4 subnetting network easily. Where it gets kind of convoluted is where you go into, say, the 8, 9, 10, 12 subnets within an organization. And most small businesses generally don't go beyond the 4 to 5 subnets anyway, okay, that you're working upon. And what I mean by that is you've got, just to be as a crude example, voice on one subnet, data on one subnet. These are going to be the crucial, at least 2 subnets on a network for sure. Okay, but most will split from there. You might have 2 voices and you might have 2 datas making 4 subnets. And then you might have another subnet out here. We'll just say another subnet might be just other, reserved for something that you haven't used anything for yet. You always want something for growth if you have to have it. A new, I don't know, a new server you implement, a new service, a new whatever. That way you're not messing with the existing voice and data. A lot of networks will actually add more than one others, maybe 1, 2, 3 others. Okay, and so once you have those subnets set up and the routing's done in the router for those subnets, you're done as far as the main homework is done for it, the background of it's done. The next thing is improved troubleshooting. Before the advent of subnets, when everything's on one tunnel, it's hard to troubleshoot, especially if you have voice and data and other all going through the same tunnel. All right, so if you have them all on separate subnets and you have a collision or something happens, say with the phones, it's only going to hurt the phone subnet. It's not going to hurt the data subnet and maybe the other subnets. Does that make sense? It's so much easier to troubleshoot. Improve utilization of addresses, because there are multiple address ranges that you can use that's given to private organizations to use, IP ranges. If they're there, we might as well use them. It doesn't cost anything to use them. It's just a matter of doing the homework and the background work to get them implemented. And then minimal impact on external routers, because Only routers within your organization are concerned with the internal routing IP address ranges. Does that make sense? Everybody outside of you could care less, okay? Like AT&T, Comcast, whoever you're connected to, Verizon, when they come into your building, your routing makes no difference to them whatsoever, zero. It's only internal. So it's minimal impact on external routers. And then reflection of physical network. Hosts can be grouped together into subnets that more accurately reflect the way the organization is used. And that's how I do it, physical network. Physical network, I've got voice on my network, I've got data on my network, and I've got a lot of other stuff on my network. The other stuff could be, say, multimedia, which is huge in campuses, right? University of Wisconsin-Madison uses multiple Mac Minis throughout their campus for all of their media servers. They've got terabytes and petabytes of storage. Just increased $2.5 million last year on just data storage alone. But they have a lot of QuickTime server applications, and what that means is, those of you maybe done video before, is students have their own, they have stations and they have podcasts. Pretty much every classroom has a podcast, and it's all televised on their campus televisions, also on all their dorms, and it's pushed through IP. It's pushed through the network, through their phones, iPads, whatever, Droid devices they've got. It's all pushed onto those devices through these network subnets, multiple network subnets on video. And video, as you can imagine, is a lot of data going through. A lot of data going through at short periods of time. And so I just read an article Monday. I don't know if you heard Apple recently plateaued on their stock market, where they're now, I think, 500 something per stock, which is, I believe, a record, if I'm not mistaken. And one of the things I think I mentioned to you last week was their new venture is cloud computing, and with all of their cloud apps, cloud sharing, even installing OSs, network operating systems through cloud. There's been some hiccups with that, but what's one of the things that Apple's known for is being kind of forefront on everything. But I guess last November, October, something like that, they bought, what was it, 250 petabytes of storage right after they implemented the iPad 2 came out. Because one of the things with the iPad 2 is they allow you to do cloud storage with everything, the iCloud with everything, which everybody's using it now. And so the reason I say that is they have multiple subnets upon their network that can do switching. Say if one network's down, it'll switch over to another network. Their routers are set up to where if one's slowing down or slowed down to a standstill, it'll switch over and switch it to another subnet for them. But it's crazy. I couldn't imagine the amount of data. You think about movies, streaming, people downloading movies, watching movies, streaming, music, and then what, iCloud. Couldn't imagine the data that they have pushing through. It'd be crazy. And could you imagine doing that in one tunnel? Not going to happen. Okay, not going to happen. So security, what's great about subnetting is security is enhanced by subnetting a single network. Making that single network into multiple subnets isolates it easily. Network admins can utilize network admin tools, make it easier to regulate who has access in and out of a particular subnet. And again, all these rules you can actually set up on the router on these subnet rules. Subnets also allow network admins to hide internal network layout if need be, out of sight, out of mind. And then VLANs. This is actually probably in the last 4 to 5 years became very popular. We have a few here on campus now. VLANs is a virtual LAN. In most network environments, networks are divided and segmented by switches like we have here in the classroom and multiple classrooms here on campus. A VLAN allows scattered users to be logically grouped together by basically virtual switches. When you set up a virtual VLAN, you're basically setting up virtual switches within your network. And there's softwares out there that allows you to actually do just that. As a network admin, be able to set up a virtual switch and tell that switch what room or what rooms are going to connect to it. But it's a virtual switch. It can reduce traffic, because if you think about it, before we had to physically move these boxes or add more switches or whatever. Now that we work in a VLAN environment for the most part throughout the campus, these boxes are going to become obsolete. In fact, in the new building, they are obsolete. We don't even use them. VLANs are definitely not the wave of the future. They are the future, because you can set up, well, we tested in this class actually. We set up VLAN also with virtual clients, to where the idea is, and here to eventually be, when students come in, you log in, and when you log in, you get your own OS for that class, your own desktop, and all the apps. We choose what you want, what we need for that class. And then each class after that has their own desktop with their own apps as well. But all this stuff is drawn down from a VLAN device virtually. And if that client poops out, you just delete it, get a copy of the old one, put it back in the slot, and you're up and going again. And this is all done through a web browser interface, basically. And the box needed, instead of the big, that's not big, the footprint on your guys' CPUs aren't big, but it's, about the size of a little bit bigger than your mouse pad, but square, and about an inch high is the device needed to plug in a USB, keyboard, mouse, Ethernet, monitor, and that's it. Everything else is driven by the network VLAN application. So that's where everything's going, as far as, with VLANs allows you the ability to do that. Didn't have that before. So in this example here, it gives looks like third floor, first, second, third floor, like we have now, a switch in each floor to drive through Ethernet cable from switch to computer, switch to computer, switch to computer. Generally from switch to switch is going to be fiber, and then from switch to core switch is going to be fiber as well, and then finally to the work group switch to the servers could be fiber as well for the most part. And that's how most networks are set up. Because you notice you just have one line running generally between the switches. Much cheaper to do Cat5 than fiber. In fact, before you guys leave tonight, you can bust open that box and look at it. We've got on the right sides of fiber between the switch to switch, and in the middle you see all the Cat5 running to your guys' computers in here. Same thing, same way this is set up here on this. And this is the way we used to set up networks, and it still works. I mean, there's nothing wrong with setting it up like this. But with VLANs, we can do it virtually now, which we couldn't do before. So VLAN basically takes place in two ways. All devices connected to the same switch, and then devices and traffic is handled by the switch itself. Devices are connected to different switches, have a special tagging within the switch itself. A VLAN is heavily dependent upon the switch for correctly directing packets. So to make a clear here, you have VLANs that work with hardwired switches, hardware switches. You also have VLANs today that work with virtual switches, which I mentioned earlier, that what we're looking into doing, having appliances run off a virtual LAN switch. That there's a website called, I think it's drobo.com, you might look up, drobo.com, that has a new hard drive technology that we're looking at for just storage. Kind of look at that if you get a chance, drobo.com. They have like, I think, a $3.99 version all the way up to like, in the thousands for business. But this would work well in a VLAN environment. Now, convergence, basically on this term is basically one of just unification of everything you have into a single IP network. So basically, VLANs allow for that to happen. So it's on one network, but you're VLANing them out appropriately for the traffic needed, whether it be voice traffic, data traffic. The advantages of VLANs are cost savings, management, application development, infrastructure requirements, reduce regulatory requirements, and increase user productivity. Because if you need new whatever in part of the building or another building, it's easier to set up with a VLAN environment. So here's some convergence vulnerabilities though, bringing everything into one. First is operating systems, like soft phones that operate on standard PCs are vulnerable to operating system attacks. So voice over IP phones like Cisco, 3Com, they have attack packets now. There's been viruses found, not many, but there's been attacks on voice over IP networks. Protocols for voice over IP. Many of the common voice over IP protocols do not provide adequate call party authentication, end-to-end integration, protection, and confidentiality. In fact, voice over IP for most businesses are fairly easy to hack into that data and to that stream. It's a newer technology. They've not really worried much on security side of it because you're talking about phones within offices, right, that hopefully are locked. And the data going across voice is voice. There's nothing else going over that. But you can actually grab a hold of that and, record, bypass it, just like you would with data packs. Lack of encryption on voice. Voice protocols do not encrypt call signaling and voice streams. And the reason for that on encryption on voice is there's so much stuff going through the tunnel, it's hard to encrypt it. It would make it so large and slow, it's almost impossible to do that with normal infrastructure that we have. So I think it's going to get there, but it's not there yet. Data acknowledgement. Attackers can flood voice over IP targets with DOS attacks. One of the things to do this is on the actual server running voice over IP or the servers, you can actually set it to not be pinged, and that'll stop that from happening to where that server cannot be pinged, that IP address cannot be pinged. And then spam over internet, voice over IP can carry unsolicited sales calls, nuisance messages, and this goes without saying. This is happened on analog phone before digital. I mean, so you're going to get it on voice too. I mean, they just throw that in there. You're still going to get, just because you're on voice over IP doesn't mean you're not going to get spam anymore. You're still going to get spam calls. Now, not as many, probably because it's a business phone, but I still get voice phone calls that are, selling whatever product that has nothing. It might have something to do with IT, but sometimes it doesn't. Something to do with, I don't know, selling real estate or something. I don't know. So you're still going to get spam through that. Now, I mentioned all these vulnerabilities. The book mentioned that there are third-party providers working with like 3Com and Cisco to, as you can imagine, take care of these things. I mean, support these type of things that are vulnerable right now. Let me ask, does anybody have a voice over IP at home through your cable provider? Anybody use voice over IP? You do? What do you think of it?
Depends on the upload speeds. I mean, because we have it for home phone. For,
right.
Family business and.
Yeah. Do you have any issues with disconnections or?
Not disconnections. Just if for some reason the upload speeds aren't up to par for some reason.
Right.
The call quality is crap.
Okay. So a lot of garbling or crackling. Okay.
Yep.
I got you. I have heard that. I've also heard it's not. You can survive a little bit, I guess, if it's voice on, if you're just talking. But I guess where the kicker is for businesses, if they're doing fax, you know how the fax has to have that signal go across to connect. If it has, I guess, have enough noise in it, it can drop that altogether on a fax call or authentication, I guess.
With a lot of the faxes too, there's like a special setting on the faxes you have to do for the
right.
over IP.
Gotcha.
So.
Yeah. Okay, I'm glad you shared that because I was wondering. I mean, we had a faculty member that had it that got rid of it because he used fax. He got it for fax only, and it didn't work. He had to go back to a regular analog phone. because he's having so many issues on some of the settings. And that was when it first came out, like how many years ago. So it's probably gotten better since then, I'm guessing.
Well, a lot of the big companies are trying to get rid of it a little bit because family noticed that a lot of their clients they're not receiving their calls
Oh, really?
because like Verizon and them are saying that it's long distance.
Ah,
And they're pretty much a lot of these companies that do the voice over IP are suing them because they're considering it long distance now.
wow. Yeah, I can see that'd be a problem. Well, thanks for sharing that, because I know that people are still buying it. It's not as popular as it used to be, but I think people are still buying it. So, okay, next one we'll talk about is Dmz Zone. These actually you can access on most of your home wireless routers, but also on any web servers or network servers. You can set this up as well. And basically, it's a separate network that sits outside of your secure network parameter, whatever those parameters are, and allows outside users to come in to access a DMZ, but they cannot enter into your secure zone. Now, Dmz ports are generally good for web servers, okay? Web servers that need to hit the outside world for a business, perfect. That web server is going to need, though, good antivirus, good updates, good security, firewalls, all that good stuff, because it's not going to be under the protection of your network and the rules of your network. But anytime I've set up a web server for a business, one of the easiest way to do it, there's other ways to do it, port forwarding and things of that nature. But to get them up and going quickly, Dmz works fairly well and easy to set up. And most of your home, like I said, wireless routers do have a Dmz port you might have seen or a setting, and you wondered what that's for. Generally, it's for setting up something from outside coming in. And then what you could do, and if you're interested in ever doing this, setting up like a little home web server to host a website or whatever the case may be. I have steps of how to do that, both working with your Dmz port and then using some free DNS relay client software for Mac or PC that basically allows you to keep that IP address that your provider gives you, like through maybe Comcast or Verizon, to where it stays sync with the outside world all the time. So if you're interested in that, let me know. I can give you steps on how to do that to where you can set up. I use it for my couple of my web classes, like PHP class. They actually can access my home server from outside, and I have it actually through the Dmz port on the Linksys router. Works really good. You set it up, set your security, and you're good to go. So here's how it works in Dmz. You'll notice on the right side, that's all in the Dmz port, and email server, web server, you want totally off the network. It's a great idea too, because we'll talk about the email server. Say if the email server gets a virus or something, which could happen, it's not going to infiltrate your local network if it's on a Dmz port, totally separate network. And so it's great to use. Then if you needed to, you could isolate, turn off the email server and fix it, but it's not going to hurt anything here in the secure internet LAN, internal LAN. This one here just shows two firewalls, a firewall here coming in. Here's your internet cloud coming into the router, a firewall for switch for the Dmz, and then a firewall for the internal LAN. Okay. So before stuff comes in from the web server email, it is hitting the firewall once again and all the rules before it gets into your internal LAN. And then NAT addressing. Most of your Wi-Fi routers and most of your network operating systems recommend NAT addressing. Basically, what this is going to do is hide the IP address of the network device from attackers. In fact, if you're having issues, a lot of times, most of your end routers today work better in the NAT environment than in the non-NAT environment. It's set up this way. And it's set up to, encourage you to use NAT translation, because if you're having issues at home, a lot of times it's because this is turned off. what it means is you can be seen possibly from the outside world, especially if you have, like I do, a DMZ port turned on. It's easier for folks to see. And all it does is basically hide the IP address of the network device from attackers. Can't see from outside. Now, is there tools like I've given you that we'll actually use this semester that allows you to see those? Yes. But the average Joe that is using a script kiddie tool or some type of game, that a lot of these stuff for NAT translation is not hackers. That a lot of times it's actually other applications or services that are looking and seeing these IP addresses and trying to glom onto them for connection. And it could be, nothing malicious about it. It just, conflict of processes and programs. So private addresses, this is addresses that all businesses for the most part will use, including our own here on campus. It's not assigned to any specific user or organization. When we go over the IP lab where we do subnetting, we talk about all the addresses, both what private ones are and then the external addresses and the ranges there. But just know tonight that there is a set of IP addresses exclusively assigned for internal organization use only, internal networks. It functions as a regular IP address on an internal network. They're non-routable, non-routable outside of your network, non-routable internally. NAT, which we've talked about, it removes the private IP address from the sender's packet and it replaces with an alias. So you've got the first two octets available, as I wrote up on the board. The last two, it puts in whatever, random numbers, which hides, and you could say, I guess, it's kind of a spoofing from the outside world. It looks as a spoofed, you could see as a spoofed device. So when a packet's returned to a NAT, the process is reversed. There's an algorithm it uses to create that alias IP address, basically. That same algorithm is used going out and coming in. So it's like a key, basically. Attacker who captures a packet on the internet cannot determine the actual IP address of the sender. So here we have coming in, here's an IP address of 192.168, which a lot of you might have at home, 0.3. The sender IP address, a packet created on the computer with this IP address. Original NAT replaces it. Notice here you have a 198.146.188.20, a complete alias IP address. And goes outside of your network and the attacker maybe sees it, tries to ping it or tries to do something with it. It's not going to go anywhere. Okay. Port address translation, it's a variant of NAT, but it's for ports only. Each packet is given the same IP address, but a different TCP port. And then network access control. This examines the current state of the network before it's allowed to connect to the network. Any device that does not meet the criteria is quarantined. Barracuda uses this quite often. Barracuda is a hardware software device that you can actually set up on a network fairly easy. And what it allows you to do is say, okay, here is my IP ranges for my network. Here's the MAC addresses for my network that's on my IP address range. It could be connected. If any device comes into my network that connects, it's not in either the IP range or generally it's set up by MAC address only because IP addresses can change. So we'll just stick with the MAC address logic. If a MAC address comes in a network that it does not know, it can give what's called limited access immediately. Meaning, say they can go through the Dmz port to get on the internet, it'll actually route them to that. So say you have a salesperson come in, they want to connect to your Wi-Fi within your business. Immediately, this translation recognizes they're not on there. It'll give them limited access through a DMZ to just get port 80 internet access so they can go on and check their email, whatever it is they need to do, but they're not going to get to your internal network. Or it can quarantine it altogether. Barracuda can say you're quarantined altogether, you're not going to get any access whatsoever. It uses this as well on a network when a valid MAC address is on a network and say that MAC address becomes infected with a malware. Barracuda has a client software that runs, and it's always looking on all your networks all the time, and say it sees something on your computer, like we'll use that Internet Security 2012 as an example. Okay, immediately sees it, pop-up comes in the person's computer, it says limited network connectivity. They try to go on the web, and a page comes up and says, Barracuda has quarantined your computer, please contact IT. The person contacts IT. They say, okay, on that page, do you see anywhere to click on to do something? Yeah, it says click here to run a scan or something. That's what Barracuda allows you to do. You can put anything on that page you want to, but they run a scan and it gets rid of that Internet Security 2012. Restarts the computer, Barracuda checks it again. If it passes, it lets them back in, all with this NAC network access control. Pretty cool control piece that you can actually use quite often. Like I said, through Barracuda, it's easily used. You can also create homegrown apps to use it. And there are things you can program in routers and switches also to work with this, and to maybe say this network access MAC address can never come into my system, possibly. As an example would be this. You have an ex-employee that is fired or whatever, and you have his MAC address or her MAC address on your system. You can put that into this control NAC and say, anytime this computer comes in, quarantine immediately, and then I want you to also text message me and email me immediately as soon as you catch it. And you can do that. Okay? The software allows you to do that. And so, great piece of great access control, basically. And the key word on this one is quarantining. This lets you to do. So things get stopped before they go any further. So the goal of the NAC, I've already mentioned it. I won't go into detail, but it's basically to potentially protect your whole LAN, basically, from getting infected. Methods for redirecting a client or quarantine a client to VLAN. You can use DHCP, ARP poisoning, and that's essentially what Barracuda does. It does an ARP poisoning, a good ARP poisoning. It ARP poisons that computer to always point to Barracuda if it's been quarantined, to where it always goes to Barracuda's website, regardless, all the time, until that quarantine's lifted. Does that make sense? So regardless of what they type in, it doesn't matter what they type in google.com, they can type in whitehouse.gov, whatever, it's going to always go to the Barracuda website and give them that message to contact IT or whatever the case may be, or to run a scan. So that's all done in this environment. Okay, last slide. Network access control architectures, current vendors, as you can guess, Cisco number one. Has network admission control is what they call it. Many Cisco hardware components for this one, tons of them. Like I said, you can configure these in routers and switches for Cisco. Microsoft Network Access Protection, primarily software-based. While I'm on Microsoft, I did install over the weekend on a computer Microsoft security tools it has antivirus, and I believe it's got, I know it has antivirus. I think it might have the anti-malware type of software on there as well. But it's totally free, doesn't cost anything. Microsoft Security Suite, I believe is what it's called. And you can download it for free from XP up, I believe, XP Service Pack 2 or 3 up, and it works pretty good. I'll recommend it. If you have somebody who needs antivirus, can't afford to buy, it works pretty good. It seems like it works pretty good. We, in fact, have it, I think, on all these machines in here now, too. And so, works real well. Juniper is a vendor, Unified Access Control. More emphasis on network hardware and less on endpoints. And then Trusted Computing Group is the other vendor. Trusted Network Connect is a product name for this. Open vendor neutral specification. And so these are the vendors, popular vendors. I already mentioned Barracuda as well. It's not on here, but that's a popular one as well. Barracuda devices start out about, for a small business, about $3,000. And then you can get, that's a small appliance, and then you can get up to like $8,000 or something like that for larger businesses. So yeah, NAC is definitely very easy, not easy way, but a good way to control malware and quarantine things, malicious activity on your network when needed. So Thursday, when you guys come to class, we're going to be doing the lab on man in the middle. I know you do come here early or you're here on time, that's great. But as soon as we get here, make sure you are here on time on Thursday for sure, because we need to start right at 4:30. And because we'll probably go all the way to the end, 5:45 on Thursday. Just because I want to make sure you guys know what happened. I also want to make sure we back everything out. We uninstall everything, put everything back the way it was, especially for the ARP tables, make sure they're back the way it was. And so hopefully by the end of the lab, you'll understand how it works, the good and bad and ugly. Also, other things you can do to maybe educate users on this not happening to them. We'll go over that. And then also ways networks can stop this from happening on their network as well. We'll actually talk about some of the technologies we talked about tonight to do that. So, all right? Any questions? Also check your email. I did update everybody's grade before you got here, or grades up through Sunday. Check the rbc.info for updates on negotiation, and I will update that accordingly. Otherwise, see everybody Thursday. If you have any questions, come and see me.